right, so I'm going to do a quick characteristics review. I'll leave you to do the graph one because I just want to show you that everything can be made a graph. If you have an equation, you're just going to type the equation in there. If you have a table, you're going to put the table in there and then make it into a function, and then you have what you need. So making this into a graph, just copying it exactly as it is. There's an error. What do you not like? You want me to add y equals. I do that and it came up. Okay, so now I've made it into a graph. So basically, if they give you a function, type it in. If they give you a table, put in the values. So let me just make some up. One, let's just say it's doubles each time. 8, 16. So once you put it in, so I'm just going to hide this real quick. Okay, you can connect the dots by hidden regression. You know it's not linear because it's not fitting. Is it quadratic? It looks like it's quadratic, but if you zoom in, so hit zoom fit, you can see it doesn't hit it. So then it has to be exponential, which fits perfectly. So if they give you a table, put it in, hit the flag, make it an equation, and then you can see the graph. If they give you an equation, just type in the equation. So in this case, I've been given an equation, so I'm going to just use my equation to answer all the questions that I need to answer. Now, a quick thing about the equations, remember you can mess with this to kind of make your views. You can tell the X where to start, where to stop, to go up by one number, to go up by 10. Same thing with the Y values. You can also get rid of the minor grid lines that we've kind of talked about that makes it easier to see. So again, just some things that you can mess with the settings. I'm just going to leave it like this just so that you don't get confused. I'm going to hide my equation because I no longer need that. I just need the graph so I can answer the questions. Now I'm going to go through all the characteristics that we've previously talked about. So if you find that I'm going too fast, please just go to the previous video where I take my time. Here, I'm just doing a quick review. So your domain is your x-axis from left. All right, so x-axis left to right. My range is my y-axis from the bottom to the top. Okay, so now I'm going to actually find, well, what is my domain left to right? If I'm not given a contextual problem, the whole graph goes. So you can see if I zoom out from the left, it goes on to where? Negative infinity. So this is negative infinity. Remember, you do not include the negative infinity because it's not an actual number, so it's open. And then where does it stop? It doesn't actually stop. It just goes on forever up and to the right, just very slowly. So again, it is to also infinity. So my domain is all real numbers. My range is from the bottom to the top. Now, a fast way for you to remember this is basically, now that I'm looking at an exponential function, you know I have an isotope. Let me just remind you what an isotope is. An isotope is what the graph approaches but never touches. So you see how it looks like it touches, what is this, negative 1, 2, 3? If I zoom in right here on negative 3, you can see that space is just getting bigger and bigger and bigger, right? If I go this way, every time I think it touches, like right there, I zoom in and you can see that space gets bigger and bigger. So your isotope, okay, is where your graph approaches but never touches. So my isotope in this case is going to be negative 3. So the bottom is going to be from my isotope to infinity. The bottom is going to be negative 3 to infinity. But this time, you are not going to close negative 3 because it never touches, it never includes it. So negative 3 to infinity. And I do want to show you that real quick from an equation. So both of them open. If you have an equation, you remember your isotope is just this letter right here, C. Your y-intercept is 2 minus 3, which is 1. So let's go see that. 2 minus 3, which is negative 1, sorry. So boom, there's my y-intercept when I add A and B. And then my isotope is just C. So we're going to make those notes here just so we can be on the same page. And please, if I misspell this, just spell it correctly. Isotope. I think it's spelled like that. Is C. Okay, so let me just write the equation in case you forgot. So you have A, B, X plus C. So what I'm saying is if you have an equation, which you can, if you're given a graph, you can put it in here and you can just look at the equation, you're going to have your isotope. And it's always this line here that goes through what? The y-axis. So if they ever ask you, well, what is the isotope? So as a matter of fact, we're going to make that one of the questions here. Your isotope is always y equals, and then whatever c is, y equals c. So in this case, it's y equals -3. Okay, so please add that question for your question here. So again, you should be doing your question as I'm doing mine. So just add isotope right here. Okay, and make sure you make y equals and then whatever the isotope is. Let's look at our x-intercept. So x-intercept, where it crosses the x-axis, is just going to click on it. For you, you're just going to see where does the red line cross the x-axis. And so let's go ahead and transfer this graph into Desmos by inputting all the coordinates we see on the graph. So I'm going to input those coordinates for you, and went ahead and chosen an exponential regression because it's supposed to be exponential. Zoom fitted the points, and you can see that it's not creating a graph that goes through all the points or creating this graph, because you can see this one passes 0, the x-axis, and you see this one doesn't. So I'm going to kind of play around with this and see how or what the fix would be. But in for the purposes of this question, because I just really want you to find the characteristics, you can go ahead and estimate for your x-intercept right here. So it's between 0 and 1, but what? Okay, so you can give me your best estimate of that. Usually the numbers that they would give you from a test or from the EOC would be numbers where it would zoom fit perfectly, but I'm going to kind of look into this further. But for right now, just finish everything just using the physical graph. So for me, it is 0.36907. All right, so where it crosses the x-axis. For my y-intercept, we've talked about this in class a lot. You're adding a plus c, so 2 minus 3 is -1, or you can just click it on the graph, which is where it crosses the y-axis, so it's -1. Now, you may be asked to write this as a coordinate, so I'm going to write this as a coordinate. A coordinate always goes x and then y, right? So x is that, y has to be 0. This is my y-intercept, so my y-coordinate is that, and my x has to be 0. All right, when is it increasing and decreasing? So in my graph, it from left to right, always, what is it doing as I go? It is increasing. So decreasing is not applicable. My graph is always increasing. So I can just say for all real numbers, it's increasing. Okay, in your case, from left to right, what's happening? All right, now positive and negative. When is the graph positive? When is it negative? So positive is when it is above the line. So I'm going to draw this line right here is y equals 0. And I'm going to double check that because sometimes I get confused with that. Sometimes I think it's x equals 0. All right, so when is it positive? Is you're looking for greater than 0, right? So you see me using the calculator to visualize it. So when is it positive? When it's greater than 0, right? And where is that? It starts right here. And where does it stop? It doesn't. So it's 0.3. So let's go ahead and write that in. 0.36907. And where does it stop? Doesn't. Infinity. Right? When is it negative? So when is it negative, which is this part, we can just change this to less than. So now it's going to be below 0. Okay, so when is it negative? It is negative starting from negative infinity all the way to this point right here, which is 0.3. So it's negative from negative infinity all the way to 0.36907. And you can do this to the nearest tenth. I'm sure it's fine. All right, so positive is when it's above the line. Negative is when it's below the line, the x-axis. And that equation for the x-axis is y equals 0. All right, what's happening at the end? So at the ends of my graph, so let's look at my left right here. So as x is going to the left to negative numbers, negative infinity, what's happening to my y? My y is coming down and never goes down below what point? The isotope, right? And remember, what's the isotope again? 2 ways you can do it. To -3, just C, which is -3, or you can zoom in and actually see the number, which is -3. It approaches -3, but never, ever touches it. So what does it do? It approaches -3. So this is how you read this. As x approaches negative infinity, as it goes towards negative infinity, f of x, my y, approaches -3. Now I'm going to do it the other way around, where as I go to positive infinity, so as my x value is going here, what is my y value getting closer to? And you can see that it's going to positive infinity. All right, so for you, As I'm going to my left, so as I go this way, where does my y value approach? And as I go to my right, as I go to infinity, where does this y value approach? All right, next one is average rate of change. We've done this quite a few times. I didn't give us a function because now you're actually going to practice this in your delta math, but I'm just going to make one up for right now. So I'm going to input a table. Remember, the biggest thing to remember about average rate of change is it's over a 2-point interval. So I guess 2 points. Okay, 2 points, must be 2 points. So if I'm given an equation, I make a table, and let's say we're finding average rate of change between 1 and 10, for example. So I want between 2 points, which is 1 and 10, but here there are way too many points. I only care about these 2 points. So I put in my own table so I can make sure there are only 2 points. So 1 is equal to what? 3. And 10 is equal to, I don't know, let's type it in and see. That. So I'm going to put that in there. And my average rate of change is my slope between 2 points. So my slope. So what does that mean? I have to hit flag, and then there is my slope. So my average rate of change, if that was the question, would be this. So the key thing is to basically, no matter what you're given, if I'm given an equation, make it a table. If I'm given a table, then look at the table. If I'm given a graph, put in your graph. So for your question, it would have been put in your graph, but you're going to do it on delta from all of them. Put in your graph for all the values, then make it an equation, and then look for the points that you need. Okay, so that's how you find average rate of change. So that's just been a quick review of characteristics that we've been doing all year. Let's practice.